Today we will discuss different types of chemical reaction, that is part 2, oxidation reaction, reduction reaction, oxidizing agent, reducing agent, exothermic reaction and endothermic reactions, corrosion, rancidity. Oxidation reaction, it can be defined in three ways: that addition of oxygen, this one, addition of oxygen, removal of hydrogen and the loss of electron. Addition of oxygen, here when carbon bonds in presence of oxygen, it produces carbon dioxide. If you see, the left side is carbon and the right side is carbon dioxide. That means oxygen is added to the carbon. That's why it is an example of oxidation reaction. Oxidation term itself indicate that oxidation means related to oxygen. Similarly, magnesium when bonds in presence of oxygen, forming magnesium oxide. Here in magnesium oxygen is added, forming magnesium oxide. These are two examples of addition of oxygen. Oxidation is also called as removal of hydrogen. When zinc metal reacts with hydrochloric acid, forming hydrogen gas and zinc chloride. If you see, zinc is converted to zinc chloride. That means here zinc is oxidized, because in this reaction in HCl hydrogen is lost. That's why we can say in ZnCl2 there is no hydrogen, only chlorine is there. That's why it is an example of oxidation reaction. Oxidation is also called as loss of electrons. Here calcium, its atomic number is 20, that means 2882. Electron configuration is 2882. That means it contains 2 electrons in the outermost shell. When these two electron is removed from the calcium atom, then convert to calcium ion after loss of 2 electron. That's why it is an example of loss of electron. Calcium convert to calcium 2+. So it is an example of oxidation reaction. Reduction reaction, it can be defined in three ways: that addition of hydrogen, then removal of oxygen, gain of electron. These are three types of reduction: addition of hydrogen, removal of oxygen and gain of electron. First point, addition of hydrogen. Here, for example, copper oxide when reacts with hydrogen, forming copper and water. Here hydrogen, if you see in copper oxide, that just you see addition of hydrogen. Here in copper oxide, hydrogen and oxygen, if they will mix, they are forming water molecule. That's why here hydrogen is added to oxygen. Then here in second example, hydrogen reacts with sulfur, forming hydrogen sulfide. Here we can say hydrogen is added to sulfur. That's why it is a reduction reaction. Then removal of oxygen. Here ZnO plus carbon forming CO plus Zn. Here oxygen is removed from zinc oxide to zinc. Here zinc oxide is converted to zinc. That means oxygen is removed from zinc. Last one is gain of electron. Gain of electron means calcium ion when takes 2 electron convert to calcium. That's why it is example of what? This is example of reduction. Calcium takes 2 electron, that's why 2 electron is added to calcium ion, convert to calcium. It is an example of reduction reaction. Then next is, what is oxidizing agent and reducing agent? Oxidizing agent and reducing agent is derived from the word oxidation and reductions, but the meaning is different. The substance which oxidizes other but itself is reduced is called oxidizing agent. And the substance which reduces other but itself is oxidized is called reducing agent. That means oxidizing agent means itself is reduced. Itself is reduced. That is very important, is that itself is reduced. That is the important definition of oxidizing agent. Similarly, reducing agent means itself is oxidized. These are two important words for oxidizing agent and reducing agent. Oxidizing agent means itself is reduced, and reducing agent means itself is oxidized. Oxidation and reduction always occur simultaneously. Oxidation and reduction reaction always occurs simultaneously. For example, you take carbon when burned in the presence of oxygen forming carbon dioxide. When carbon burns in presence of oxygen forming carbon dioxide. Here carbon is converted to carbon dioxide means carbon is oxidized. If carbon is oxidized, if carbon will be oxidized, then automatically here carbon is oxidized to carbon dioxide, automatically oxygen will be reduced. If carbon is oxidized, oxygen will be reduced. Just opposite, because oxidation and reduction always takes place simultaneously. If one is oxidized, other will be reduced. Similarly, if you see the example that zinc oxide when combined with carbon monoxide forming zinc and carbon dioxide. Here if you see zinc oxide convert to zinc, that means loss of oxygen. Loss of oxidation, loss of oxygen means it is a reduction, because loss of oxygen is reduction. Here CO2, if you see CO2 carbon monoxide is converted to carbon dioxide. So carbon monoxide is converted to carbon dioxide means here carbon monoxide is added with oxygen. So carbon monoxide is oxidized and zinc oxide is reduced. But what is the definition? Our definition is itself is reduced is called oxidizing agent. Here which is reduced? Zinc oxide is converted to zinc means it is reduced because loss of oxygen. So zinc oxide is oxidizing agent. And carbon monoxide, here carbon monoxide is oxidized to carbon dioxide by addition of electron. That's why itself is oxidized. CO is oxidized means it is an reducing agent. Just opposite. Oxidized means reducing agent. Reduced means oxidizing agent. Just opposite. So like this. So zinc oxide is reduced, so it is oxidizing agent. Carbon monoxide is oxidized, so it is an reducing agent. Okay. Then next very important reaction is exothermic reaction. Exothermic reaction, how can you identify? It is always produce heat. Always produce heat. If heat is produced, that is called what? Heat is produced, that is called exothermic. Example, what are the example of this? Examples are acid plus base produce salt and water and heat. If you see, if you add acid to base, it produce salt and water. How can you know it is exothermic? Because heat is produced. Heat is produced means temperature of the medium increases. The temperature of the solution increases. Similarly, other examples are carbon when burned in presence of oxygen forming carbon dioxide, heat is produced. Burning of coal. Magnesium when burned in presence of oxygen produce magnesium oxide, it is also heat is produced. So these are called exothermic reaction, that means heat is produced. Exothermic reaction always accompanied by what? Always accompanied by rise in temperature. Always accompanied by rise in temperature. Always temperature increases. Always temperature increases. So this is called exothermic reaction. Then let us see one activity. You see here some concentrated HCl is taken in the conical flask. Then thermometer is inserted. The temperature of thermometer, temperature of the acid in the conical flask is measured. How much temperature is showing? Exact temperature. You see from the slide you can see how much temperature? 33 degrees Celsius. Temperature is showing how much? 33 degrees Celsius. That is the 33. That is the temperature of HCl taken in the where? In the conical flask. Then what we will do? We will add sodium hydroxide solution to the concentrated HCl solution. What happens? A reaction takes place. But you see the temperature reading in the thermometer. You see temperature suddenly increasing. It increases. How much? Just you see the temperature is obtained in the thermometer. The thermometer reading shows how much temperature? 60, 63, 64, 65 temperature. That is how much? 65 degrees Celsius temperature now obtained in the solution. The temperature of solution is now showing 65. That means it was earlier 33, now changed to 65. That means temperature is increased. When the reaction, the temperature increases, that means heat is produced. That's why it is an example of exothermic reaction. Endothermic reaction. We can see endothermic reaction. In endothermic reaction, what happens? In this type of reaction, heat is absorbed. In this type of reaction, heat is absorbed. Glucose plus water. If you add glucose to water, then the glucose solution will be prepared, but you see the temperature of the solution falls. Temperature decreases. Similarly, when you heat mercurous oxide, which oxide? Mercury oxide. If you heat mercury oxide, then it produces mercury and oxygen. Similarly, if you heat calcium carbonate, it produces calcium oxide and carbon dioxide. That means these two reactions require heat. That means here heat is absorbed. When heat is absorbed, that is called endothermic reaction. That means it requires heat. It takes heat from the solution. That's why it is called endothermic reaction. Other type of, that is one exothermic, another is endothermic. Heat is released means exothermic, heat is absorbed means that is endothermic. And all endothermic reaction showing fall in temperature. Temperature falls. But in exothermic reaction what happens? Temperature rises. That is the difference between endothermic and exothermic. If you see one activity, that now some water taken in the conical flask, then to the conical flask some glucose crystals added. Some amount of glucose added to the solution, added to the conical flask containing water. If you see, then temperature, earlier it was 30, 32, 33 degree. Now the temperature changes to how much? If you see, observe the temperature, how much coming temperature? Now temperature showing in the thermometer that is below 30 degree. Temperature showing just below 30, 29 degree. So that means temperature, here temperature falls. That's why it is one example of endothermic reaction. When temperature falls, it is called endothermic reaction. So two types, exothermic and endothermic. In endothermic, temperature falls. In exothermic, temperature rises. Then next is corrosion. What is corrosion? In this type, in this process, what happens? The metal is converted to, metal is transferred to a new substance, undesirable substance is formed on the surface of metal when it will be exposed to air. When it will be exposed to air, then a coating of unwanted substance is produced on the surface of metal. That is called corrosion. Generally corrosion, during this corrosion what happens? The metal, it causes damage to the metal and also it causes the disintegration of metal. That means what happens? Due to corrosion, the thickness of the metal after some days will be reduced due to formation of what? Unwanted substance. When the unwanted substance is removed from the metal surface, then it will be disintegrated, the thickness will be reduced. It will be corroded. That is, mainly corrosion involves oxidation. Mainly it involves what? These three things is important. It involves oxidation. Oxidation of metal into metal oxide, hydroxide, then sulfide, convert to sulfide, sulfide or carbonate. Like this, metal will be converted to metal oxides, hydroxides, sulfides and carbonates. So these are the very important properties of corrosion. That means metal will be converted to oxide, hydroxide, sulfide or carbonate. These are the characteristics of corrosion. What are the examples? Greenish layer of copper. If you see, after some days copper become greenish color. This is due to the corrosion of copper. And blackening of silver. Silver ornaments will be black because due to formation of silver sulfide. Why greenish layer of copper is formed? Because copper is converted to copper carbonate and copper hydroxide. Blackening of silver, that is due to what happens? Silver is converted to silver sulfide. Similarly, iron, you have seen, iron also convert to iron oxide or iron hydroxide. It may be black color or maybe reddish color will be formed. So these are the examples of corrosion. Then how the corrosion will be affected? What are the factors affecting corrosion? Mainly for corrosion, it requires air containing oxygen, carbon dioxide and sulfur dioxide. These are very two important gases. Carbon dioxide and sulfur dioxide, oxides of nitrogen are essential formation of corrosion, and oxygen is highly also essential. Then during corrosion, and another thing is important is moisture. If water particle, if moisture in the atmosphere is more, then corrosion will be faster. And corrosion will be also more if the medium is saline. That means if it contains salt. If that means in saline belt, in coastal belt, corrosion is faster. Temperature is also another important factor. At high temperature, your corrosion will be faster. Another thing is some metals will not be easily corroded, although it is more reactive, but not easily what? Not easily corroded. What are the examples? The examples are aluminium oxide. Aluminium oxide, this very stable oxide, this aluminum oxide is very stable. Once a coating of aluminium oxide is formed over the aluminium, then it prevents the further corrosion. That's why aluminium metal, aluminium utensil will not be easily corroded because due to formation of stable oxide layer over the aluminium. Similarly, in presence of acid, corrosion will be faster. If medium is acidic, corrosion will be accelerate. Will be more faster. If medium is basic, corrosion will be slow. So these are the very important factors. What are the factors? Atmospheric oxygen, then carbon dioxide, sulfur dioxide, saline belt, then air containing moisture, then high temperature, and it also, in this case, corrosion will be increased. But if some stable layer, stable oxide layer is formed over the metals, then corrosion will be slow. That example is which one? Zinc oxide, aluminium oxide. If it is formed over the metals, then corrosion will be slow. Then acidic medium, corrosion will be faster, but in basic medium, corrosion will be slow. Okay. Then prevention of rusting. How the rusting will be prevented? Very important for this. First one is by electroplating. That means coating of a superior metal over the inferior metal. The substance which is corroded, which will be rusted, that means iron will be rusted. Over iron we can coat what? Copper, nickel, gold, silver, like this we can cover the aluminium. This is called electroplating. Covering of a superior metal over the inferior metal. That is called electroplating. That is, we can electroplate iron, other metals by copper, nickel, gold, silver, zinc, like this. So this type of metal will be, this metal which will be corroded will be used as cathode, and which metal will be used for electroplating, it will be used as anode. That means copper, nickel, gold, silver, zinc will be used as anode, and the metal which will be electroplated will be used as cathode. Suppose iron, it will be used as cathode. Then another very important method for prevention of rusting is galvanization. That is coating of zinc over iron. Coating of zinc over iron, that is called galvanization. In this way, the iron rusting will be prevented. Another is using anti-rust solution. What are the anti-rust solution? Alkaline phosphate, alkaline chromate can be used to prevent rusting of iron. Painting, greasing, also important. Nowadays we are doing this thing, very easier methods. Then making into alloys. If metal will be converted to alloys, for example, iron convert to steel, stainless steel, so that what happens? Rusting will be slow. Rusting will be prevented. Steel, brass, like this. When we will convert steel, brass and bronze, it will be prevented for rusting. So when metal will be converted to alloys, then rusting will be slow. Okay. Then another very important thing is that is rancidity. That is, this is the important thing for our day-to-day life. Because when we are preparing our food, if we keep the food for many hours, then it will be give foul smell, change in color. That is called rancidity. That if you keep oil, fats or cooked food when exposed to air, if you keep in outside, then it show change in color, taste and smell. This is called rancidity. This is called rancidity. Rancidity means it is also oxidation process, because atmosphere contain oxygen, then this oxygen oxidizes the food materials. Then it shows change in color, taste and smell. That is called rancidity. It is an example of oxidation process. We know we are using different dry fruits. We are keeping the dry fruits. We are packing the dry fruits using nitrogen gas, because the nitrogen gas prevent the oxidation. Night is a very stable gas, very stable element. It prevents the oxidation. That's why we are filling nitrogen gas in your dry fruits to prevent oxidation, to prevent rancidity. Then you can use antioxidant. If you use antioxidant also prevent the rancidity. Then if you keep our food in airtight container, also food can be prevented from oxidation, from rancidity. So rancidity also very important process to where the food particles will be destroyed. To protect this damage, that spoiling of the food, we can use different things for the prevention. What are the prevention steps? That keeping the antioxidant, some adding preservative, or keeping the substance in the nitrogen atmosphere, or keeping the food substance in airtight container. So that another factor also temperature. If temperature is very low, also rancidity can be checked. So these are the very important application of this chapter. Okay, thank you.